In this video, we'll go through an example of a coding question you might be asked in an initial screening. Here's the question. So consider you have a coin, you flip it 30 times and receive 20 heads and 10 tails. What's the probability of this result from a fair coin? And then if we were to update this statement to be more in line with how we calculate p-values, how would we calculate this value? So in an interview, they would probably just paste this question into some sort of text editor. Here I'm using a notebook, but we'll kind of go through an example of how we would follow the steps to get to a solution in an initial screening. So the first thing is just to note there are a couple parts to this question. The first part is consider you have a coin, you flip it 30 times and you receive 20 heads and 10 tails. What's the probability of this result from a fair coin? So you might ask some clarifying questions, make sure, is there a fair coin flips 50% heads and 50% tails? That I imagine to be the case. You could just make sure that that is what the interviewer has in mind too. And then some other questions that you might ask up front are, am I able to Google? Is this something that I should be able to do without using additional resources? In most initial screenings, companies are usually okay with you Google searching. They even like seeing your mindset for doing that. In some screenings, you can check online and see if they sort of go against that and they want you to just be able to do things off the top of your head. But in most cases, I've seen screeners usually are like, yeah, you can Google, just show your browser, show me what you're looking at. So in this case, if we're doing this first one, let's imagine that we're able to Google search and we consider a fair coin. It flips 50% heads, 50% tails, and we flip it 30 times and receive 20 heads and 10 tails. So in general, I sort of think of this as right away in my mind, I go to a binomial distribution. So this is a binomial distribution, n equals 30. That's how many times we flip it. And we're asking what's the probability that x equals 20, right? So I think of it as what's the probability x equals 20 given x follows binomial, basically 0.5, 30, right? This is what comes into my mind. This is how I think about it. And so then the next thing is just depending on where you're coding, here I'm in Python. The other thing that comes to my mind is I think that there's probably a way to do this in NumPy or in SciPy. And so I would go to those documents. And if we were to search the SciPy docs and look for a binomial distribution, this is the link that you'll find. So here's the distribution. And you can see it's ScipyStats.binom. And then they have a bunch of different examples. And down at the bottom, they kind of have a whole bunch of things that would live on this. And so this would show your familiarity with some of these things. The main ones being sort of RVS is to do random draws from this distribution. PMF is a probability mass function. So that's that equal sign. And then the CDF is a less than or equal to. That's the cumulative. Those are the ones that I think show up the most frequently. And so in this case, actually, if we're doing this probability x equals 20, in my mind, that's this probability mass function. And so you can see it takes a k, an n, a p, and then a location. So in this case, k is how many successes there were in n flips with some probability. In our case, a fair coin is 0.5. And so in an interview, you would just want to walk the interviewer through your mindset. In this case, again, I would say, I have a probability mass function that looks like this. And here's sort of the documentation that I would go to in SciPy. And so if we use this, it looks like this binom, PMF. And then again, from the documentation, we can sort of see what the order of those items are. It's K, N, and P. So K is this 20, N is 30, and P is the 0.5, right? Okay. So for this first one, it looks like the probability of this result from a fair coin, this 20 heads and 30 flips, is 2.8%. Right, so this is the first part. And now we can move on to the next part. So if we were to update this statement to be more in line with how we calculate p-values, how would you calculate this value, right? So here, I guess there's a bunch of things to clarify. So in a p-value, we usually have like a null and alternative hypothesis. And so the null hypothesis in this case, I would clarify, I would think of it as the coin is fair, right? So, and then the alternative would be the coin is not fair. And so in line with p-values, how would you calculate this value? Usually a p-value, so in this part, the interviewer is likely looking for you to define the p-value. So a p-value is, right, the p-value is the probability of obtaining your statistic. So in this case, the 20 heads and 30 flips. Or something more extreme, so farther from a fair coin, if the null is true, right? So the p-value is the probability of getting this 20 heads and 30 flips if the null hypothesis is true, right? If the coin is actually fair. So in this case, now we're looking at the CDF version of this. So I kind of visualize this as, right, like the probability of getting 20. So this is like the probability of getting 20 or 21 or 22 all the way up to 30 heads out of 30 flips, right? And so I would just clarify that, like when I think of a p-value, it's the more extreme away from the fair coin. So the fair coin would say, hey, you should see 15 heads and 30 flips. That's exactly fair. And then anything like the observed value, this 20 heads, or something more extreme away from a fair coin is sort of the way that we view a p-value. So 20, 21, 22, 23, all the way up to 30. And so in this case, this is a CDF function. And if you'll remember, and we can just check the docs again. So again, if we're Googling here, so it takes things in the exact same order. It's a cumulative distribution, and cumulative distributions, I always think of them as these continuous things, even though this is discrete, but like you think of them as shading to the left. So basically the CDF actually gives like 19, 18, 17, 16, etc. It goes the opposite direction. So if we do the cumulative distribution up to 19, and we do 1 minus that, and again, n is still 30, and the coin is still fair. So we're sort of saying, hey, what's the probability of getting 19, 18, 17, 16? And then we're going to take 1 minus that probability, and that'll give us basically the opposite part. So in this case, that looks like it is just under 5%. 4.9%. So here, the answer to the first question is 2.8%. That's the probability of getting 20 heads and 30 flips. And in the second question, the solution is 4.9% chance of seeing this result sort of in a more p-value way, which is under this definition. So in your interview, I think they're looking for you to define a lot of these things, to clarify these points, and then at the end sort of just arrive at a right answer. This is an example of a question you might see really early in the interview process, just to make sure that your fundamentals are strong. You're familiar with things like p-values, different statistical distributions, PMFs versus CDFs. There's a lot of different moving components here. In this video, we'll go through an example of a coding question you might be asked with an initial screening. And so here's the question. Consider you have a coin, you flip it 30 times, you receive 20 heads and 10 tails. What's the probability of this result from a fair coin? If we were to want to update the above statement to be more in line with how p-values are calculated, how would you calculate this value? And then there's a note here to use simulation to answer each question. So there's essentially two questions here that we're looking to answer. And the note is that we want to use simulation. So if you saw another version of this video, essentially we didn't use simulation. We used the raw functions from SciPy to be able to answer this. And so you might see this as like an extension within the same interview, or you could imagine that like you want to be able to answer these probability-based questions just in a simulation-based way without having to have memorized all of these statistical distributions and like the difference between PMFs and PDFs and CDFs and PPFs and, you know, all of these different things that come in the SciPy documentation. So in this example, we would ask similar clarifying questions. We'd make sure that we understand what a fair coin is. We would define what p-values are. You could imagine that you're getting all of that information, giving all of that information the exact same way as in the other interview. In this one, we just kind of want to go through the mindset of how this works with simulation. We can again, in this particular case, you could imagine that we want to do this without having to look at documentation. So a couple of things that you might have memorized are how NumPy binomials work, or how random draws work, or how to build your own functions to be able to do random draws. Any of those is an acceptable way to approach this. So in any case, let's go ahead and dive right in and look at this first question and how we would do this. And again, sort of the mindset that you would help the interviewer follow you through this process. So the first thing that I might do is just say, you know, we have these 30 flips, we get 20 heads and 10 tails. Since we're going to do this with a simulation-based technique, I'm going to use the binomial distribution from NumPy. So I'll go ahead and import that. And then I would probably just illustrate how this works for both a reminder to myself and to the interviewer. So I would do something like random.binomial, random.binomial, and then I think it's like how many draws you want to do, and then what is the probability of a success from that draw. So this would say, hey, flip the coin once and give it a 50% chance of being a 1 or a 0, where 1 is heads and 0 is tails. So in this example, like we flipped it once and we got, say, a tail. We could just do this a couple of times to make sure that, okay, this time we got a 1, so we can see that we're getting these random values of 0 and 1. And then you could see like what happens if we do 10. So you can see it doesn't actually give us like a vector of 0s and 1s. It gives us some number. So it's saying, hey, you got 3 heads out of the 10 flips in this case. So now the question here is, what is the chance that you flip 30 times and you get 20 heads? So if you did it one time, it would be like, hey, you flipped it 30 times. And we're kind of asking, what's the probability that this lands exactly on 20? So here it landed on 19. If we do it again, it landed on 17. Do it again, 18. So we're getting these different number of heads every time that we do it. And we're asking, you know, how often does this exactly happen, that we get these 20 heads? And so I would probably just do this. if we're doing it with simulation, I would just do this a whole bunch of times, count how many of them had 20, divide by the total number of times that I ran the simulation, and that would be my answer. So let's go ahead and we'll write a list comprehension to do that. You could imagine doing it in just a simple loop as well. But so we're going to do this for, I'm using the underscore here just because we don't need to store anything, and range, or we don't need to use this value for anything. And you could imagine like we could do this 100,000 times or 10,000 or just 1,000, something like that. And we could just say, this is going to be my results. So, and then if we look at the length of results, that should be the 100,000. It's super fast. And now we're kind of just going to say, take the sum and, So if we look at this, right. So each of these is like some result from 30 flips. And basically we want to look at like, again, I'm just going to do this as a list comprehension. One, if val equals 20, for val and results, right? And we probably could have done this right in here too. We just checked this value each time, but this is kind of nice because then you have the results in case you want them for anything else. And then we would just divide by this here. So this first part is basically saying, hey, give us a 1 back if it's 20, and then divide by the total number of times that we did this. Oops, and I got an error. Let's do, I think the if goes at the end unless you do an if else. So let's try this. Okay, great. So in this, what is this? In the 100,000 flips, we see that 2.8% of them had an exact value of 20. And if you look at the result from SciPy, so if we do like SciPy.stats, SS, Binomial.PMF, and then 20, 30, 0.5. And you can see that the result from SciPy is right around that 2.82, right? There's going to be some variation because, we're running a simulation, and this is like the exact value. Cool. So that's the answer to the first one. This is kind of nice because then you can double check your answer if you're familiar with these built-ins. And so then the second question is like, how would you update the statement to be more in line with how we calculate p-values? So again, here I would define the p-value. The p-value is the probability of getting your result, or one more extreme, if the coin is truly fair, right? So I would probably just write that out again. It helps with my mindset. So the p-value is the probability of this result. That is the 20 heads for one more extreme. That is farther from a fair coin. If the coin is truly fair. Right, so just having this p-value statement memorized is a good idea, and just like having a really good familiarity with how it works is important. And so in this case, I would just say that means we are looking for the probability of 20, 21, 22, all the way up to 30, right? So it's still the same. Again, if you watch the other video, it's the same. But now we're going to find this using our results. And so the second part is actually really easy if we stored all these values, because we just change this to, instead of equal to 20, we say they need to be greater or equal to 20. And then we'll take those as one. So more extreme is those that are 20 or greater. We count those, we divide, and you can see that it's right around the 5%. And again, if you're familiar with the built-ins, we could just double check. That's always kind of nice if you're familiar with these built-ins. So if it's a CDF, we take 1 minus, and we want 19 instead of 20. And you can see it's also right around 5%. So yeah, it's always nice when you can like simulate and then also double check this answer with what the calculation for this actually would give. Cool. And so as a clarification for your interviewer, the first answer looks like it's about 2.8%, and the second looks like it's right around 5%. So if we were to say, hey, what's the next part that your interviewer might look for is like, so how likely do you think it is that the coin is fair given that you saw these results? I don't know, like this is right at the cusp of how businesses usually make decisions. So p-values of 5% are right at the cusp. And so they might be looking for some back and forth. Imagine you saw this in a real situation. How would you use that 5%? What would you do? In this case, you know, it looks like this is significant. And that means that like, it's pretty unlikely that you'd see this 20 heads and 30 flips from a fair coin. So it suggests to me, it seems unlikely the coin is fair, but it's certainly possible. So yeah, then bringing this back into any business context is probably the last part of an interview. But a lot of times in these initial screens, they're kind of just making sure your fundamentals are there. And then in follow-up interviews, they might go into the depths of how you interpret these values, how they might get used in practice.